Who studied at the University of Virginia and taught for 8.5 years in the California State University system before joining BIRAC in January 2014. Since joining the VA, she has focused her efforts on the corporate data warehouse. I'm pleased to welcome today's speaker, Margaret Gonslin.
Thank you, and thanks to everyone for joining us today. So I will be moving through this talk. Before I begin, I would like to acknowledge feedback from Richard Pham at Bissell and my colleagues here at BIRAC. Thank you all very much for your important help. And also, I'd like to remind everyone that this is part of a series, as mentioned in the advertisement, that begins with the first-time user's guide and works through the starter SQL language, so that may be helpful for people who are new to this subject. And first, I'd like to know just a little bit about who's in the audience, so if you would please answer our quick poll here. Which of the following best describes your role in the VA? Would you say, and please check all that apply, research investigator / PI, career development awardee, data manager or analyst, project coordinator, operations, partner research or QI, or something else?
And unfortunately, I did not have enough options to put everything in here, so for those of you looking for a career development awardee, unfortunately, that's not on the screen. If you want to put that in other and type that into the question screen, we can definitely categorize it there. Responses are coming in nicely. I'll give everyone just a few more moments before I close the poll question out and go through the responses. And it looks like things are slowing down here, so we will close it out. And what we are seeing is 19% research investigator or PI, 66% data manager or analyst, 9% project coordinator, 18% operations partner research or QI, and 9% other.
Thank you very much.
Oh, yep, we have informaticist, VA fellowship, or the other comments that we got in. Thank you, everyone, for participating.
Thank you, Heidi. And thanks, everyone, for answering our poll. Okay, moving into the talk now. By the end of this talk, I hope that someone who is new to CDW would be able to understand the logic of joining tables or views within a CDW domain, be able to write a query that includes an inner join statement, be able to incorporate some best practices as they do that. So in order to accomplish this goal, I'm going to cover three main topical areas. The first one is the background concepts that are relevant to CDW, relational databases in general, some basic SQL to review some of the content from the previous discussions in cyber seminars, and some best practices, new and old, based on the past cyber seminars. And then we'll move into the second section of the talk, which is going through the logic of an inner join using a simple example. And finally, in the third section of the talk, I'll apply this to the CDW, going step by step through the process of joining tables from the corporate data warehouse. And first, we'll do 2 tables or views, and then we'll join 3 tables or views together. So beginning with a background or conceptual overview, this will review materials from the past cyber seminars just to make sure that everyone's on the same page and remembers those concepts before launching into the inner join. So once again, tables are sets of columns and rows, spreadsheets, if you will, that contain data elements. So here's an example of content from one CDW table on a patient level of analysis. So what is a view versus a table? A view is the result of a stored procedure that pulls information out of the database or table into a virtual table. So in simple terms, it's a virtual look at the table. And so the view of this patient-level table down here would look exactly the same. So from the perspective of an end user, there is no significant difference other than the fact that when an end user goes to use the corporate data warehouse, they will be working with views to maintain the integrity of the data that is found in the table underneath it. To review a few concepts from basic SQL language, we're going to start with the commands select and from. And as you'll recall, select allows the programmer to list the columns or variables that they want to see in their result set, and remembering that each column should be followed by a comma, except the last one in the list. Just doing this alone is considered a best practice because it's going to limit the size of your request instead of asking for every column in a table. Also, in every SQL query, you'll need from to identify the table or view from which the columns will be collected. And you will name it, as you see here in blue, database.schema.table. Most queries will want to add a where statement to limit their search to only include a chosen subset of data that they're interested in rather than trying to look at all of the data in the corporate data warehouse. And this will be especially important when working with large fact tables in CDW, considered a best practice. So for example, if we put these 3 pieces together, we would have the select statement followed by the columns that we want to see in our result set. We would name our table in the from statement here, and then we would follow it with a where clause, identifying some sort of criteria to limit the size of the output. Another way of sort of moving forward with a best practice in CDW is to use the command called top. When you're first drafting your SQL query, this can be really helpful to make sure that the logic of the query is working properly. And what it does is allow you to choose a small number of rows to test your query on. So you add it to the select statement of a SQL query, and then you follow it with the number of rows you want to test your query on. So if we take a look at the sample query here, you can see the top command in red. So you would select the top 100 rows to test your query on, and then you just write a normal query. You start listing your columns that you're going to choose, you name the table they'll come from, and then you may or may not have a where clause to indicate who should be included. Another helpful shortcut that would help the programmer move a little bit more quickly through their queries is use and go. What this does is allow you to name the database that you're going to use at the beginning of your query so that you don't have to repeat it throughout the SQL query as you move through writing it. And this becomes more important when you start to join tables together because each time you name a table, you'll have to repeat that database. So you can see in this example language here, you would use a certain database, say go, and then you'd write a normal query, but in the from statement, you would take the name of the database out. And you'll see as we start to perform joins that this can be very useful and saves the programmer a fair bit of time. Okay, a few more concepts before we get going with joins that we just want to bring fresh into your memory are dimension tables and fact tables. That all data warehouses contain multiple kinds of tables, and those 2 kinds are dimension tables and fact tables. So what is the distinction again? Dimension tables, they tend to be smaller tables, and the CDW, they do not hold sensitive information typically. They are sometimes called supporting tables because they are meant to be accessed repeatedly, so that can include things like diagnoses. Every time a diagnosis is delivered, that table holding the diagnosis is repeatedly accessed. Fact tables can be especially large in the CDW, into the billions of rows in those, and they tend to hold substantive data about some sort of topic of interest. And in the CDW, they also contain sensitive information, and their access to these is controlled through a process of applying for access through national data systems. So another key concept moving forward that will become especially important in joining are the joining keys. As I mentioned in previous cyber seminars, there are two kinds. The first kind is called a primary key. It is a column that exists in every table that uniquely identifies each row in that table. And a foreign key is a column in a table that corresponds to or references a primary key in another table. So as a visual reminder, we'll move into the simple example that I used in the past cyber seminar. And if you'll recall, we have three tables here. The first one is a customer table. It's a fact table containing information about each customer that's come into, in this case, the store. We see the dimension table called item table, and we repeatedly access this information about which items were sold in the store, shirts, pants, skirts, etc. And then the third one is the purchases table, a fact table about which purchases have occurred and when. Each one of these tables has a primary key as its first column. You can see in customer key in the customer table, item key, and purchases key. Each one is going to uniquely represent each customer, each item, or each purchase. And if you look at the second column in the purchases table, you can see that it is a foreign key connecting over to the dimension table with the items for sale. And if you look at the third column in the purchases table, you can see that it is a foreign key connecting to the primary key in the customer table. So if we were to read across the first row of the purchases table, we could see that the first purchase was for a shirt, and it was purchased by Mariana Jones. That's what the two foreign keys of one and one would mean. And this purchase occurred on January 1st, 2014. Okay, before we move into the inner join, I would just like to ask our audience one more question about themselves, and that is asking people if you would please rate your CDW experience. So how would you rate your level of experience with CDW on a scale of 1 to 5? 1 being not worked with it at all, up to 5 being very experienced with CDW. And I'll turn it over to Heidi.
Thank you. We'll give everyone just a few more moments to finish responding there. Responses are coming in nicely. We'll give it just another second or two before I close things out. Okay, so what we are seeing is 30% saying they have not worked with it at all, 37% rating a 2, 24% rating a 3, 6% 4, and 2% very experienced with CDW. Thank you, everyone.
Yes, thank you, everyone. So I believe that this series is at the right level here for working your way into the CDW for the first time. So hopefully it will correspond to your needs. All right, so now we'll move into the second part of the lecture on the logic of the inner join. We're going to stick with the simple example for now just to show how it works in a visual way. So the inner join is a SQL command that will allow a user to keep only those records or rows that match in both of the tables that are being joined at the time. So here we have table A and B, and an inner join is going to allow us to keep only the overlapping part of the two tables. So in order to write this into our SQL query, we would add a clause beginning with the command inner join, and that clause would follow the from clause in the SQL query. It would look like you see here in blue. There's a second part to the inner join clause that begins with the command on. And following the on command, you will put the name of the first linking key, an equal sign, and then the name of the second linking key. So in practice, it would end up looking like this. You would have your select and your from statement using it in a typical way. In the from statement, you would use the name of the first table you're going to join together. And then in the inner join statement, you would name the second table that you want to join to the first table. And then the command on, and you see the name of your two linking keys, your linking key from the first table and your linking key from the second table. Order isn't important in that. So let's just take a quick look and think about some of the best practices in the process of creating that join. We want to, if possible, join the dimension table to the fact table. So what does that mean in practical terms? It means that we would put the fact table in the from statement of the SQL query, and we would put the dimension table in the inner join statement of the SQL query if possible. So it would look something like this. We would use a certain database. We would say go. We would select, as always, our columns of interest from table 1. And if you have a fact table and a dimension table that are going together, we would put the fact table in the from statement as a best practice and inner join the dimension table there. So let's put this into practice with a simple example. If you'll recall our tables from the previous slide, here we're going to join this dimension table full of items to the fact table full of purchases. And in the red circles, you can see that we're going to pull out only the columns, item from the dimension table and date from the fact table. And we're going to want to join on the primary key, item key, to the foreign key, item sold key, in order to bring our tables together. So in the end, we would write a query that looks something like this. Select item and date from purchases table, that's our fact table, inner join our dimension table on our two linking keys here with an equal in between. So let's do this one more time with a simple example, because this will illustrate an important point in addition to our query and why we should use it. So here we'll try to join these two fact tables on customers and purchases. We'll choose the columns you see here in red circles, and we'll join on the appropriate primary and foreign key. So we would write our query so far the same way we have been writing it. We would select our three columns from the red circles. We would, in this case, we have two fact tables, so order is not important. We would start with the first table in the from statement, inner join the second table, and then after the on command, we would have our two linking keys. But this query is going to fail. Why is it failing? Well, there are a number of possible reasons for that failure. Here in the select statement, we have last name, first name, and date. These are the three columns that we selected for inclusion in our result set. But these may not be unique in the overall data warehouse. They may exist in other tables, and so they could be overlapping, and the program is not sure which last name or which date you're referring to. Another possible source of error could be the non-uniqueness of the names of these two linking keys. They are both named exactly the same thing, customer key. So the software is confused about whether it comes from the customer table or the purchases table. Therefore, we want to be able to clear this up. One way you can do this is to add the name of the table to the front of the name of the column or the name of the joining key so it explains which table it comes from. So for example, for last name, we would put the name of the table it comes from beforehand, store.customer table. Same thing with date. For the joining keys, we'd be doing the same thing. For each one of them, we would put the name of the table in the front of the name of the joining key. And as you can imagine, then you would write the query that is quite long like this. Select our three columns have become a very long name, store.customertable.last name, and the same thing is happening in the on clause where the name of our primary and foreign key are becoming quite lengthy. So typically people avoid this with the use of what's called an alias. And it's a shortened name that you're going to substitute in for the name of the table inside your query. Okay. So the way that we create an alias or a shortened name for the table is with the command called as in SQL. So for example, in our from statement where we listed the first table name, store.customertable, we would add the command as, and then following that we would give a shortened name to this table. Right now, it's just the letter A, but you could put anything you'd want there. And then in the inner join statement, you see the name of the other table, purchases table, and the command as, and then the shortened name of the letter B. And then you take that A and B, and you put it in front of each one of your columns. So A.last name, A.first name, B.date. It's saying which table it came from in the shortened way, and the same thing for your linking keys. So now we'll put that together in our example, right? And so now you can see that in our select statement, we have the aliases of A, and B. So A is referring to the customer table, B to the purchases table, and the same thing in the on statement where the A and the B are explaining where the primary and foreign keys are coming from. And so now SQL knows where to look in order to find the customer key that you happen to be referring to at the moment. All right, so now we'll start to apply that in a step-by-step way to the corporate data warehouse. All right, so for today's example, I've chosen to look at CPT codes that are associated with outpatient procedures. So as always, with the CDW, it's really important to make sure that you have the columns you need and you know where to find them in which domains and which tables. So the only place to really find that out is in the CDW metadata report. So I'll take you there and we'll walk through the parts that we need for today's lecture. And it'll be important when we're there to look at the table level metadata to find out what's inside each one of those tables that you'll be using. And it's also important to look at the ER, or entity relationship diagram, in order to figure out how to join the tables together, because that will display in pictures how the tables relate to one another. So to begin, we would go to the CDW metadata report and select either one of the links that you see here in red circles. And that will bring us to this page where we will click the pink execute the metadata report here near the top to arrive at the metadata report for the corporate data warehouse. In this page, you will see each domain of data listed in alphabetical order, starting with allergies, moving to appointments, consults, and so forth. And if you want to find data that we'll be using today, you would have to scroll down to get to the outpatient domain for procedures and CPT codes. And then you would want to click on the plus sign in the box to the left of the domain name so that you can open up the table level metadata report for each domain. So, pretending now that I have scrolled down the page, you would arrive at the outpatient domain there on the left-hand side of the screen and click the plus sign next to that domain name. And the names of the tables would open out to the right as you see here on the screen. And you can see that right away near the top of the list, we find dim.cpt, the table we need in order to be able to find CPT codes. And we would need to scroll down in the table list in order to find the fact table that has the procedures in it. So, pretending that we've done that, we've looked at the description of everything in each one of these two tables. We would then decide which content was important for our study. So in the procedures table, we would find that there was the date of the procedure, the date of the encounter, and any comments related to it. When we would read the report for the dimension table with CPT in it, we would find that we would have the code, the name, and the description for that CPT, any category or major category that it belongs to, when it became active or went inactive, and, if applicable, any appropriate age range or gender that might be specific to that code. Okay, now, as I mentioned earlier, we would also want to take a minute to look at the entity relationship diagram in order to figure out how the tables relate to one another, so that we can successfully join them together. We would do this by actually clicking on the name of the domain there that you see in the red circle, and it will open up the image in a new window. So I'm showing you part of the image that opens up because it's quite large and you can't see it all at one time, or it's very, very tiny if you look at it all at one time. So I've highlighted here the section that pertains to the two tables being used in today's example, and I've given them an alias here in the picture with a red A on our outpat B procedure table, that's a fact table, and a red B on the dimension table with CPT. So how do we connect these two tables? We look in both of these boxes here, we're looking for primary and foreign keys. Primary keys are typically the first thing listed in each one of the tables, so you should look at the top of the box to identify the table's primary key, and it will have in parentheses PK. So in table B, we see CPT SID is the primary key for that table. And in outpat B procedure, we see B procedure SID is the primary key. How do we connect these two? We will connect it on the foreign key from the fact table A with CPT SID to the primary key in the dimension table. And while we're here, we should pick which columns we'll want to include in our query. So in green now, you can see that we'll choose visit date time from table A, CPT code and name from table B. Right, now it's time to open up SQL Server Management Studio. You'll want to go to whichever server you've been given access to and expand databases. And then for dimension tables, you can look in CDW work. And for fact tables, if you're a researcher, you will want to go to the folder created with your data extract for your research project. And they will tell you what it's named. Once you're scrolling through the list, you would find your tables of interest. So here I found outpat B procedure, and the column I'm going to use is in the red box there. And on the right-hand side, because we can't see them all at one time on the screen, is the second table and the columns that I'll use from it, vim.cpt. So just as a reminder, we're going to do an inner join and /on clause after the from clause in the SQL query. We're also going to use the command as to alias the tables, the columns, and the joining keys. And we're, if possible, going to put the fact table in the from statement and dimension table in the inner join. This should be familiar. And so when we apply that to the CDW, we can see that we're using CDW work. We're selecting only the top 10 to test the query. We've listed our three columns that we chose. We've started in the from statement by naming the fact table and alias and giving it an alias of A. Then we follow that in the inner join statement with the dimension table and give it the alias of B. We name our two joining keys with aliases A and B. And we have a where statement to only select those cases where the visit date time is not null. All right, now let's take the same idea and apply it to 3 tables or views. And so again, with an inner join, we're only going to get the part where tables A, B, and C overlap. And it's quite easy. We're just going to take the same basic logic, except this time we're going to have 3 tables. And I've given them aliases here, A, B, and C. So we've added a new table, dem.cpt category, and I'll take a look at the metadata to examine its content in just a second. We already know how to connect table A to B. And so we just needed to figure out how to connect table C into either one of these tables. We could connect either one, but we found the connection between table B and C on CPT category SID. And we're going to select only 2 columns. The first one's from table A, visit date time, and the second one is from table C, major CPT category. And in this case, we're only using B to pass through to table C. We're not collecting any column from it. So a quick look at CPT category is going to give us the category and major category, the type of category, the source, and any restrictions on the range of codes that are appropriate to that category. And we would again want to find this in SQL Server Management Studio in our Object Explorer. We'd find our table, dem.cpt, and then find the column we're after and just make sure that everything is coherent and our plan is going to work out. Okay, so how do we join that third table? We do it the exact same way. We add another inner join clause and another on. So we have our first table there in the from statement, our second table in our first inner join, and its linking key to follow that in the on clause. And then our third table is exactly the same. Inner join, third table, give it an alias, have on, and then list your linking keys with the equal sign in between. So, and when we put this into practice in the corporate data warehouse, we can see it playing out. We've already selected our database at the top with the use and go, and then we selected top 10 to run our test query. We've selected our 2 columns with our aliases A and C, indicating that we did not select anything from the second table that has an alias of B. And we can see our inner join statement here with our third table, dem.cpt category as C, on our 2 joining keys of interest. In this case, our joining keys are connecting it to table B. And we still have our same where statement, and our output is down below in the image. So to summarize, inner join can be used to pull together information, overlapping fields and columns from many views and tables, many more than 3 if you wanted to. And while you're doing that, it's important to use best practices in order to get the most out of CDW. These are numerous, but in today's lecture, we hit a few examples, such as joining your dimension tables to your fact tables, using aliases, reducing the size of your query with a where statement, and that sort of thing. So I'll move into questions if people have any. And here's my contact information. And just to point out here, there are a couple of bonus slides at the end saying a few other best practices where there's logical language, but that is permitted. However, it is not recommended for various reasons listed on those slides. So I'll take questions if there are any.
Great, thank you, Margaret. And yes, there are several questions here for you, so I'll start going through them. One of the first ones is about the use and go you mentioned in the background. The question is that the same as choosing the drop-down option of the SQL Server?
No, I would assume you mean the sort of right mouse click and select the top 1,000, so I'm assuming that correctly, which kind of writes a little automatic query for you. The use and go just specifies the name of the database that you'll be working with, because in the corporate data warehouse, there are multiple folders available, and I was going to try to find an image here to show what I'm talking about. Let's see. Hold on. So you see each one of these in the Object Explorer is actually a different database. And when I say use and go, I'll be telling SQL Server Management Studio to go to a specific database in this list called CDW Work in this example. But you may be going to some other database listed in the corporate data warehouse if I understood the question correctly.
Okay, the person just commented that it's an option to choose the database that you will use for your query. If you select new query, and then there's a drop-down option above the Object Explorer. Is that correct?
Yes, I would think so, yes. I always just write it in there, but yes, I would think that might be the case. Mm-hmm.
Great, thank you. Is it possible to use alias without the as?
Yes, it is. Mm-hmm. Okay. It just makes it a little bit harder to read sometimes.
Okay. Mm-hmm. Next question. I see that the commands are written in capital letters. Why do that? Is it a best practice or personal style preference?
I think it's just sort of tradition. That's the way all the training manuals put it. SQL Server Management Studio is not case sensitive. So I think it just helps when in training to highlight which words are commands. They also color typically in SQL Server Management Studio, but you can, that depends on settings and personal preferences. There's no particular reason to have those commands in caps. I just think it helps it stand out when people are first learning. It helps me.
Okay. Question refers to the entity relationship diagrams. What do the different dotted lines mean? Some are blank, some have white circles, some have black circles. Can you explain that a little bit?
Yeah, so in the entity relationship diagram, these lines are intending to help you understand which tables connect to one another. So, for example, in this image that's up on the screen now, it will tell us that outpat v procedure connects to dem.cpt, and then you can see that the lines that lead out of dem.cpt will connect us to the 2 tables on either side of it, but there's no line, say, going to outpat.v scan test. So you can see there's no direct connection between dem.cpt and outpat.v scan test. So if you wanted to connect these 2 tables, you would have to indirectly go through another table to connect them. But there is a direct connection between the dem.cpt category, as we just saw, and dem.cpt. So it's just sort of noting where the connections will be direct, and or if you want to indirectly connect 2 tables that do not connect to one another, you can work your way through those lines. There's also another way inside the CDW metadata report itself that will allow you to see how tables connect anywhere in the CDW to each other. I couldn't fit it into the time slot for this cyber seminar, but that'll be part of the next one in the series to show those connections through a tabular format as well, just in case you're interested.
Great. Related to this example, is the ER diagram the best way to know that dim.cpt is not sufficient, that I also need the fact table outpatient.procedure?
I would assume so. I mean, I think part of, it depends on, I guess, what each person is bringing into their sort of looking at these diagrams. So it's hard to say if there's one answer to that. But I would say in general, these diagrams can give people a pretty decent idea of what's contained in the table. But I always go to the CDW metadata report and look at the content in each column in the description that is coming from the VISTA side to make sure that what something is named is reflective of what it actually is, because that can at times be somewhat misleading. But also in the dependency part of that question, I would think that for the most part, it does help people to see that you need to use them together in order to make sense of the situation, because the CPT table will just do nothing but include the list of CPT codes and their descriptions and so forth. In order to figure out what diagnosis of a patient had, you couldn't just look at the ICD-9 table. You would have to connect it to a visit or an inpatient stay or something like that. Same thing here. You would have to connect it to the actual procedure. But I think that can be the difficult part for people who are new to the relational database, as it was for me when I first started, that each one of these tables has its own unit of analysis. So the CPT table's unit of analysis is the CPT code, and the procedure table's unit of analysis is each procedure, and the patient's is each patient, and so forth. And that's why you need to bring them together.
Okay. Next question. Do we always use the primary key from the dimensions table to connect to the foreign key of the fact table, or might it be reversed in some situations?
It can be reversed. There are all kinds of different nuanced scenarios that I come across all the time. Also, a foreign key can be used to connect back to the primary key in its own table. To pull out previous records, like a previous prescription, for example, you would use a foreign key inside the prescriptions table, for lack of a better word right now, and connect it to the primary key in that table and pull out past prescriptions or past fills. For example, the same thing happens with past enrollments in the enrollment table. So there are lots of different kinds of scenarios that play out in the CDW in relationship to connecting foreign and primary keys.
Okay. All right, next question. Last week I looked for metadata for information on the PCMM database, but it was very limited. Are there any plans to include more metadata for that database?
Well, I'm not sure about that particular set of metadata. I can say that in general, metadata that is associated with CDW comes from the metadata of VISTA when the source of the CDW data is VISTA. So, for example, what's available in the metadata for the data architecture repository for VISTA is the same metadata that gets pulled into the CDW. So I would look for that kind of an answer, probably in the package from which the primary care management module comes from, unless it's some kind of alteration done by CDW.
All right. I have a couple questions here about whether or not there's a particular order in joining tables. Is there certain logic when you're deciding what tables to link first and second?
For me, other than the fact table being in the from statement, there's no particular reason for choosing to be this table first or that table first. I tend to start with the table that I'm most interested in, and I also tend to start with what I think is the largest table and join other things to it. So if I had two fact tables, I might put the larger of the two fact tables in the from statement because it makes things run a little bit more smoothly when you execute your query. It should save you some time to have that there because of the way that SQL runs. And, that's just what I've been taught. And so I practice that as a matter of, sort of saving time and computing resources.
Okay, great. So where do you define your aliases?
I'm sorry, could you repeat that?
Where do you define your aliases?
In the query, like here, I'm just defining my aliases when I'm thinking about how I'm going to write my query. So, as I said, this is completely arbitrary. So here I randomly assigned the alias A to the outpat procedure and alias B to the dimension table for CPT. And then I just had this in my mind, and I wrote my queries to match that. And so in the query, I added it here in the from statement and again in the inner join statement. So after the name of the table in the from statement, I have my first alias as my alias A, and in the inner join statement, I have my second alias as B. And then I use that A and B alias throughout the names of the columns in the select statement, and again through the names of the linking keys in the on statement.
Okay. Under what circumstances would you do an outer join?
If you only want to have parts of one table, you want only things that exist in one table and not the other, so you only want to pull it in if it exists in table A and not in table B, then you start to do outer joins, left joins, right joins, unions will bring everything together that coexists between two sets. So you start asking yourself these questions as you can use basically the same exact logic, except here instead of inner you want outer, you want left, you want right. You start telling it whether you want to pull things from the table in the from statement or in the join statement or in both statements, or you can create joins that pull. It just depends on where you're putting your first table and your second table, or your third table. So it basically is saying it's allowing left and outer and right are saying you only want bits from the various tables of choice. So you just substitute in that language in your query and sort of read through the example, but you do it the exact same way. So it's pretty easy to just start extrapolating and reading what you would prefer to do given your circumstances and your questions that you have in mind for your research.
Okay, great. Next question. When I try to join different views from patient.patient, primary key, via patient SID, it multiplies the results. Why is that?
Okay, can you say it one more time? I think it's probably joining a mini-to-many, but can you repeat it one more?
Right. When I try to join different views from patient.patient via patient SID, it multiplies the result. Why does it do that?
I guess I would have to kind of see the exact thing that is happening in the query, but my guess is that you must be joining some kind of foreign key. I'm not sure. I mean, I think it's pretty specific and would have to sort of look through the query and see exactly which table was being joined and problem solve from there. But it sounds like for example, in some cases, depending on exactly what you join, you're having multiple matches. So it would expand the number because it would be creating more records each time it matched. But I couldn't answer more specifically, sorry.
Okay, then maybe I can just email you with a more specific question.
Sure.
Moving on. I can create and join 3 temp tables with a left and right join, but when I try to join a 4th temp table, the query goes up to 2 hours. Can you explain that?
No, I'm sorry. I would have to defer to someone with a lot more years under their belt, as I'm only learning as I go as well. So.
Okay. This next question is specifically relating to the content on slide number 45. Does an inner join schema.view2 as B override the content of as B previously defined?
I'm sorry. I'm on the right slide 45?
Yes.
Okay, repeat it one more time.
Doesn't inner join schema.view2 as C override the content of as B?
Oh, yes. I apologize. I've overlooked a typo. I meant to put view 3. So if you wouldn't mind correcting that, I will be correcting it as well. Thank you.
Perfect. Okay. Mm-hmm. We still have quite a few questions, and we still have 8 minutes, so I'll continue going through those.
Okay.
Can you show how to get to ERD one more time?
The ER diagram? Mm-hmm. Okay, so if you start out on the CDW metadata page, the list of domains that you find there, each one of them is actually a link to the ER diagram. So when you click on the name of the domain, a new page opens up in your browser, and you can see the actual ER diagram. Since you can see my slides, I think I can just show you in real life. We'll see. So, like if you are here, it's always good to have the URL saved if possible, because it's often difficult to re-find. So I'm going to the metadata page here on the SharePoint site. It takes a little bit to load, but when you click it, it will open the name of any domain. It will open that ER diagram. It's a little bit slower than I hoped. So for allergies, I would just literally click the name of the domain, and there you have it. And if you want it to get larger, you just click anywhere on the image, and then you can move around within there to find various parts of the domain or tables that you are interested in.
Okay. What does the where clause signify in the example that you gave us? More specifically, the is not null part.
Okay, so any and all the where clauses will just basically allow the user to specify some kind of condition that would be met in their example. So here, when we are looking at the where clause, we could put anything in, but is not null is a sort of CDW way of saying it is missing. It doesn't have a value of null in it. So it has some date time in the actual field of some sort. Now, it won't do that perfectly, but basically any where statement will allow you to do this. And people often use where statements so that they could say, look at only the last year of data. It's really good for dates and things like that. Or maybe only patients where they have diagnosis of some particular illness that you might specify in a where clause. And so the example of is not null is just one example of a kind of where statement that you could use to only look at records if the field actually has a value in it that is valid in some way. So here, when we take a look at this output at the bottom of the screen on the right-hand side, you can see that visit date time, the column that we asked not to be null in the where statement, has a date and time there for each one of the records that returned in our test query of 10.
Okay, I think we have time for maybe one more question. How about when you join 2 tables from 2 different databases? If you have a use statement, will you then specify the other database in the remainder of the code?
I would think so, yes. I would think in that case, you might put, instead of a use, you might just go ahead and put the name of the database for tables from source A in the actual query itself, and then source B later on when you're joining tables from the second source. So you may not be, I'm not sure if this shortcut would do you any good in that case. You may just put the name of the table, put the name of the database next to the tables as they're coming from different sources. That would be my guess.
Okay. Margaret, thank you so much for your presentation. If anyone still has any questions that were not answered, or if you have any other additional questions, you can email us at byrick@.
Certainly. Thank you so much. Margaret, I also want to thank you for presenting today. We very much appreciate the time you put into this. For the audience, I will be closing the meeting out in just a moment. When I do that, you will be prompted with a feedback form. Please use it. Please, we ask that you fill it out with some feedback today and let us